Hi, my name is Mario Chavez, and this is my final presentation for ECE595 Power Electronics class, Professor Jared DeHoro. First, what I have here is my schematic, and what this schematic is, it's a 12 watt 5 volt buck converter. What this circuit does is it takes 12 volts, it bucks the voltage down to 5 volts, delivering 2.5 amps to the 2 ohm load resistor. Now what you see here is a power transistor right in over here. This capacitor just for stability, noise suppression. This Schottky diode, which turns on during the off state. Here is my buck circuitry. Here's the capacitor, inductor 29 microhenries, 2.2 microfarads, and that 2 ohm load that I talked about. This is just a power meter. This is an oscilloscope measuring the current to the output and the voltage on the output. And this is another oscilloscope that measures the switching frequency input into the transistor. So let me go ahead and turn these on so we can simulate this and run it. And it's a previously saved waveform. I will go ahead and run it again. And you can see there is our switching frequency right over here, and I'll move this up. I'm using an 11 volt input to the transistor, and what I have here is this is at 400 kilohertz frequency, which gives me a 2.5 microsecond pulse period, and I'm using 1.125 microsecond pulse width, positive pulse width. Now here is my current signal. This is the output current, and this is my output voltage. Move this crosshair out to about here, and you can see right here that the output voltage is 5 volts at 2.5 amps. This is voltage representative of current. So it's at 2.5 amps, 5 volts gives me 12.5 watts on the output. Now let's show you this circuit again. That's a simulation circuit, and here is my built circuit, with right here being my power transistor, and that has a heatsink because it's delivering a lot of current. Here's my Schottky diode. The first cap is my inductor, the second cap, and here is my power transistor, which is also heat sunk because it gets really hot with 12.5 watts. Here is my pulsar, and as you can see, it's 2.5 microsecond pulse width for 400 kilohertz. My pulse width is 1.3 microseconds, gives me that pulse width. And the output right now is off. Here is my power supply giving me the 12 volts out and no current, so right now is off. Once I plug this in, I can be safe to say that it's still gonna be off. And then when I come back over here to my circuit, and let's adjust this so you can see my oscilloscope. So what I have on channel 1 of my oscilloscope, that is going to be on my switching frequency. Channel 2 is going to be on my output voltage, and channel 3 is actually the output voltage coming out from the transistor. So you'll see what's going on here. So I'm going to go ahead here and turn the pulse on. Turn my scope on. And so the yellow is representative of my switching frequency. Right here, this light blue, that is my output voltage. and this is the output from the transistor, the voltage on the transistor. So if we zoom in right here, you see channel 1 amplitude 12.2 volts. That's my switching voltage. And the channel 2, this one down here, the mean, my output is 4.98 volts, 5 volts approximately. And as in our simulation with the 12 volt output source, it is sourcing around pretty close to 2.5 amps, giving me my approximately 12.5 watt output. Thank you.